Hello friends, welcome to the session. In this session, we will be discussing about Thevenin's theorem. Thevenin theorem is very useful theorem with the help of which we can simplify very complex electrical or electronic circuits. So Thevenin theorem is useful whenever you have been provided with a complex circuit and whenever you have been asked to analyze the circuit in order to find out the value of voltage or current in the circuit. Friends, as you know that we are recording this session by using iPad and we will be making the use of suitable softwares. So let us understand what we mean by the Thevenin theorem. Thevenin theorem is a theorem which will tell us to simplify a complex electrical circuit. So any given complex circuit, any given complex circuit can be simplified by using Thevenin's theorem. So whenever we have been provided with a complex circuit, then this circuit will be converted into a series voltage source, we will convert it is voltage source and a series resistance. So this series voltage source is being called as the Thevenin voltage source, and normally we will use the letter such as VTH, and the Thevenin resistance is the series resistance, and normally we will make the use of letter RTH for the series resistance. So any complex circuit can be converted into a simple circuit by using Thevenin theorem, and this circuit will consist of a series voltage source VTH and a series resistance RTH. So now let us understand how it is possible to convert the given circuit into a Thevenin equivalent circuit. So this circuit is being called as a Thevenin equivalent circuit. So the steps for conversion of the given electrical circuit into Thevenin equivalent circuit is like this. First of all, decide where you have to apply the Thevenin theorem, and the 2 points need to be decided, and for these 2 points you need to open the circuit where you have to apply the Thevenin theorem. So apply the Thevenin theorem at particular points in the circuit where you want to determine the value of voltage or current. Then in the second step, you need to determine the value of the Thevenin voltage source called as VTH. In the third step, you need to determine the value of the Thevenin resistance called as RTH. And then finally in the fourth step, you can find the value of current or voltage at particular points in the circuit. So these are the 4 steps that you need to follow whenever you want to apply the Thevenin theorem to the given electrical circuit. So you need to decide at which points you have to apply the Thevenin theorem. Then you have to determine the VTH, then the Thevenin resistance RTH, and then you will get a simplified form of the given circuit through which you can find the value of current or voltage at particular point in the circuit. So let us understand with some simple example how it can be achieved. So let us consider a circuit. Suppose I will consider a simple circuit. Suppose we have been given a battery of 12 volt, and suppose there are resistances such as 2 ohm resistance. This is another 2 ohm resistance, and suppose here I will connect a 2 ohm resistance, and suppose these are my points A and B, and now I want to determine the value of current I flowing through this 2 ohm resistance connected between the points A and B. So I have to apply the Thevenin theorem at these points A and B. So the steps will be like this. First of all, you need to open the circuit where you have to apply the Thevenin theorem. So I will modify the circuit now in such a way that I will remove this resistance temporarily between the points A and B. I will reconnect it later. And this is a 12 volt voltage source. Now here I will get the value of VTH, which is the Thevenin voltage between the points A and B, which is 12 divided by, first of all, I will get the value of current, and then I will get the value of voltage source. So 12 divided by 2 plus 2, that is 4. Therefore, I will get the value of current as 3 ampere. And now my VTH will be the voltage across this 2 ohm resistance. So this is just nothing but 6 volt. So my voltage source VTH becomes 6 volt. So this is the first step. Now in the second step, what I will do, I will reduce this battery 12 volt to 0, so that I will get the rest of the circuit like this. And now I can find the value of RTH. So one can easily find that this 2 ohm and this 2 ohm resistance are in parallel with each other, and therefore I will get 2 parallel to, which is just nothing but 1 ohm. So this is my RTH. Now in the third step, I will modify the circuit. This is VTH, which is equal to 6 volt. This series resistance RTH is equal to 1 ohm. And then I will connect now this resistance between the points A and B, which is a 2 ohm resistance. So now I can easily find the value of the current I flowing through this circuit, which is 6 volt divided by 2 plus 1, that is 3 ohm, so which is just nothing but 2 ampere. So now one can easily observe that we are able to find the value of this current I equal to 2 ampere. And in order to find this value, what we have done is that we have used the Thevenin's theorem. That is, we have converted this circuit into this simplified form so that we can easily obtain the value of the current flowing through the resistance 2 ohm. So friends, whenever you want to apply the Thevenin theorem to any complex electrical circuit, then determine the points where you have to apply, open the circuit, determine the Thevenin voltage source VTH, determine the Thevenin resistance RTH, and then finally you will get a simplified form of the circuit through which you can easily find the value of voltage or current flowing in the circuit.